Good morning, good afternoon, good evening, everyone. The GROW meeting starts in 1 hour. The GROW meeting has been postponed for 1 hour to accommodate a scheduling conflict for one of the presenters, and because the GROW agenda allows to be shorter than 2 hours. So feel free to get coffee, tea, all at your own cost. We start at 2 p.m. Central European Time in about 58 minutes.
Hey, Joe, are you going to start soon?
Hey, Jared. The GROW meeting has been delayed by 1 hour. It will start in 56 minutes because of a scheduling conflict with one of the presenters and the fact that the GROW agenda was shorter than the 2-hour block allocated to it. So get some water, get some tea, some cereal. I'm going to put up a slide that indicates that we're starting a little bit later. Apologies.
Oh, okay. Got it. All right. I'm going back to spring.
Hi, everyone. We are going to start in about 4 minutes. So this is last call on coffee. 4 minutes, then we'll start.
Good morning, Job. Microphone check.
Jeffrey, I can hear you loud and clear.
Okay, thank you.
Test.
Hello, everyone. Welcome to the Global Routing Operations Working Group meeting at IETF 110. I think today's meeting was originally envisioned to take place in Prague, but unfortunately all of us are gathering in our houses wherever that is on this planet. That will not take away from the joy of this meeting. But before we start, I would like to draw attention to the IETF Note Well. This is a reminder of IETF policies that are in effect on various topics such as patents or code of conduct. If you're not familiar with the IETF Notewell, please review the reference documents at a later point in time. As mentioned before, we started 1 hour later. This was because there was a scheduling conflict that we could not resolve at the last minute, but it appeared to be a simpler solution to just start this meeting 1 hour later. In today's meeting, we're going to cover the administrativia, some BMP and Yang-related reports from the hackathon, a new initiative called BMP Seamless Session, and an update on the internet draft about ASPath prepending. If you have questions, please drop them in the chat or raise your hand. In terms of staff completeness, Christopher, are you around? Yes, you are. So for the administrative side of things, we need a minute taker. Is there a volunteer who wants to contribute a summary of what is being discussed on the Etherpad?
I think I can probably do some Etherpad. I just need to find it.
It's real easy. You go to IETF.org. You don't click the live, but you click IETF 110 online, and then you don't click agenda, but click agenda HTML. And from there, you can easily go to. And
You forgot where you raise your left foot.
All right, so we got a minute taker in the shape of Christopher Morrow, and then I will volunteer to monitor the Jabber room. Oh, an update about the charter. At the last meeting, we discussed that a charter refresh was requested by the area director, and we faithfully labored to produce an update to hopefully align the work of this working group more with what was described in the system. And this charter update was discussed in the working group, and to me it appeared that most in the working group had an idea of what the update meant and what this working group does. But when it was brought forward to the IASG review stage, a lot of questions came back where apparently there is still some work to be done to make this charter understandable, not just by the working group participants, but also by people who review our output. So I have it on my to-do list to go over the feedback from the IESG review round and incorporate that feedback into a revised charter proposal, which I'll then share with the working group mailing list. And if people feel that that is a good update, then we'll try again with IESG. So the update is that the charter update is an ongoing process and might take a few more months. Other administrative things we need to discuss. I think that's it for now. I'm going to hand over the microphone to Thomas Graff, who is going to share with us an update on the BMP Yang hackathon.
Okay, can you see and hear me?
We can see and hear you. Take it away.
And how about the screen sharing? think I requested. You just need to grant and then it should work. Yes, excellent. Okay, can you see the screen?
Yes, we can. Thank you.
Oh, excellent. Then I will start with the first slide deck on last week's IETF 1010 hackathon. So I'm representing here the BMP and the Young group. So in the hackathon, on the BMP part, we were focusing this time solely on performance and not on functionality. So here, our interest was basically we want to see how BMP adjacency RIP in, out, local RIP, including path marking TLV, is affecting the CPU and memory consumption, but also when congestion on the network is happening, so BGP start sending a lot of updates and withdrawals back and forth. If on such circumstances we can ensure that the RIP, which is collected through BMP route monitoring, is always, like the mirrored RIP is always representing the same state as we have on the network. And last but not least, we also want to understand if a router in transit, if BMP is enabled or not, what the difference is in terms of BGP route propagation delay. So that's from the BMP part, where on Young Push, briefly, we're focusing on an open source implementation on these two drafts here, and focusing there also on performance tests. This was the software we've been using throughout the hackathon. That's the network. So on the very left-hand side, we had EXA BGP generating the BGP updates and withdrawals. We had here 61 router being a route reflector, 52 another route reflector, and 62 basically a provider edge router receiving and installing the routes. And basically here in orange at various points, we were enabling BMP, either adjacency RIP out or in, pre, post policy, or also local RIP coverage and basically doing the described tests. So what we achieved was this time on the lab environment that we have now a fully automated test setup in terms of generating the sequenced BGP updates and also initializing the BMP the right way, how we want to do it, and then basically collect BMP metrics from the network and through Young Push, the CPU and memory BGP process usage. So we can monitor basically prefix loss, also metric loss in BMP, and the CPU memory usage we can go down to BGP process level. As a next step for the next hackathon, we defined that we want to do the same tests also in a multi-vendor environment and cover different operating systems. And also we want to work on some timestamping approval. This is basically what we did on the UDP notif side. Here, mainly the focus was implementing a data collection library, which was written in C, and also a mockup producer, both supporting segmentation in UDP, and it has been integrated into the PMACCT open source network data collection. That was a test message we generated into Apache Kafka for Young Push. This was a test performance setup we did with Young Push. Very impressive were the throughput we achieved with Young Push. I think this is one of the most fastest implementation currently available. So on one core with 500,000 messages, we were achieving up to 11 gigabits per second with jumbo frames. So Here, basically, the test setup from the network side. So, as I mentioned, we enabled BMP at various points, and we're measuring the effect of the BMP. What was really impressive was that even though we had congestion, so a lot of, we were generating up to 1 million routes on the network, that under no circumstance we had loss of metrics. So in all cases, basically the RIPS rate could be achieved. That's one good notice here. The other one is in regarding BGP propagation delay. We discovered that the accuracy of the timestamping was not accurate enough, so therefore we could not draw final conclusions how much impact BMP brings to the BGP propagation delay. So there we're going to improve the timestamping accuracy, and we're going to do the tests in the next IETF hackathon. Here are some examples on the tests we did. So the test setup generated 1 million BGP VPN v4 unicast passed, and it was advertising it as fast as possible to 10 peers. And as you can see here on the very left-hand side, the CPU usage basically during the BGP propagation period, wherever BMP was off or on, did not change. But later on, basically when the propagation was through, and then basically the CPU usage went back down to normal, the export started to perform, and during the export period, we basically had the same amount of peak that we had during the BGP propagation period of time. In regards of memory consumption, we can see that once the prefixes are being propagated, initially we are consuming more memory on the BGP process, but throughout the test cycle, that did not change. That was on the route reflector, and the same we got experience also on the provider edge router with the same RIPS enabled, so no change in there. Then we did another test, basically on the route reflector, where while propagating the BGP prefixes, we were flapping the BMP. And here, basically, we could saw that there are no impact in memory nor in CPU usage when BMP session is flapping. So what we learned this time in the hackathon, it's basically, since it's the fifth time, we were more prepared than we were before. Test automation was very important, and also being connected throughout the hackathon with Slack and MS Teams. And of course, since it's all virtual, we all miss beers and cocktails afterwards. Many thanks to all the participants. So, any questions on the test results?
I see Jeffrey stepped forward to the queue.
Sure.
Go ahead, Jeffrey.
Thank you. Thomas, first a question about the test methodology for the route reflector. On the slide there, you're showing that BMP is kicking in much later than the BGP convergence. Is that because BMP is being enabled after the fact, or is there actually a gap there where the system's converging in some fashion?
Actually, the implementation looks at the CPU usage, and at that point in time when the congestion is happening on BGP, the CPU level is higher than normal, and therefore the export is being delayed.
Okay, so the implementation in question is choosing the wait and defers advertising BMP.
Exactly.
Okay, thank you. And my second thing is an observation about the timestamping. I certainly cannot speak for other people's implementations. Junos has second level granularity for its timestamps. It does not waste the extra space to keep something less than that. We put in effectively a increasing counter in the additional field to make sure that if we have more than one event within the same second, that you get something of no use to let you know the sequencing. But so the two observations are that the timestamp will be closer to second level granularity for at least one implementation, and the second observation is that the timestamping is going to be somewhat separated from the BGP events in some cases based on pipelining. So if you just think about the time it takes for a packet to be placed on the wire by a transmitter, and maybe TCP delays before it's pushed processed in the queue, potentially with some additional wiggle room, within a second granularity as this being run through the BGP pipeline.
Okay, thank you very much for the input. We'll take that as a notice for the next test setup. Yeah. And we do saw different vendor implementations have different implementations on timestamping, and we noticed that Juniper Juno does both seconds and milliseconds. Yeah. Great. Any more questions or remarks?
If there are no additional questions at this point in time, I would like to invite you to continue with the BMP seamless session presentation.
Sure. Then I will have over to the second slide deck in here. Can you see the slides?
Yes, we can.
Perfect. So I will start, since I'm representing here Swisscom, I give a short overview where we stand currently on network telemetry data collection. I think probably the easiest is to look on the very right-hand side, the three graphs. Basically, the first one shows how many messages per second we are producing in terms of IP fix. The second one in YANG push, and the third one into BMP. And as you observe that BMP is quite bursty, and if you look at the count, basically, if you have a burst that it can easily have been higher than the IPFix data collection. So from an evolution point of view, I can say that as per end of last year, we were collecting roughly 2,500 from 2,500 devices network telemetry data with BMP, IPFix, and YANG push, and we had up to 1 million messages per second in peak, and we are considering onboarding up to 40,000 devices this year, and then with up to 10 million messages per second. And from these 40,000, most of them, 38,000, will have BMP enabled. So if we look at from these 2,500 devices, only 300 currently have BMP enabled, and those 300 devices contribute basically in peak to 600,000 messages per second, but in average, very low, 8,000 messages per second. So that gives you more or less a picture how much data is being exposed from the network and the burstiness of BMP, especially with the adjacency rip-in. And this is the point which we try to address in this draft, or basically to optimize. So one angle is we want to try to avoid data duplication, and the reason why we want to avoid data duplication is because in the BGP network, basically the amount of BGP paths are in a service provider steadily increasing, but also on the other hand, thanks to the new support of BMP, now besides adjacency rip-in, adjacency rip-out, also local rip is being supported. So therefore, basically more metrics are exposed, and those metrics, thanks to the TLVs, contain more and more additional information. So overall, basically the amount of metrics from the routers is steadily increasing. So duplication needs to be prevented, and we see that those duplications happening most of the time when the BMP session is re-established, and we see basically there are two main contribution factors why this BMP session is re-established. One is a brief loss of connectivity between BMP client and server, and the other one because the BMP server is taken in maintenance, being restarted, and then the BMP session is re-established. So if we look a bit more closely into the BMP session handling, so section 3.3 in RFC 7854 describes basically that if the TCP session towards the BMP server is established or closed, then also the BMP session is established and closed. And in section 5, basically, that it is described that once the BMP session is established, the initial RIP dump with route monitoring messages is performed. And this RIP dump is performed regardless if a BMP session is established or re-established. TCP fast open is defined in RFC 7413, and basically it gives us the unique capability that we can distinguish between an initial TCP establishment or a re-establishment of the TCP session. And this draft is not only suggesting to use TCP fast open for the BMP session, but also on the BMP application, on the BMP client, extending the BMP session lifecycle. So the BMP session should not be closed immediately when the TCP session is closed. There should be a configurable timeout value. And if within this timeout the TCP session is re-established, then basically the BMP session is considered to be still up. Another angle is that that the client needs to buffer messages between the TCP re-establishment. And the BMP session is declared terminated when either the buffer is full or the timeout is reached of the BMP session closure. What we wanted to preserve in this draft is the key principle of BMP, that is, it is still a unidirectional collection protocol. The suggested extensions are optionals, so either the TCP fast open TCP session is supported or not, and as described already in RFC 7854, that a buffering on the router can happen, and in most implementations today we've seen that it is happen, and this draft is makes basically use of such a BMP buffer, so the message can be preserved between the TCP re-establishments. So this is 0.0 version. We are looking very much feedback from the Grow mailing list. We would love to hear your comments and feedbacks, and also if this draft has merit or not, and whatever you think about TCP fast open, or whatever you would prefer to have an implementation be done within the BMP application. But keep in mind, if the implementation needs to be done in the BMP application, we cannot preserve the main principle of BMP, that it is a unidirectional protocol. That's all from my side. Any questions, remarks, feedback?
Speaking as just working group participant, I would encourage you to continue this work. I think that the effects on real-life networks of session flapping and the consequences for subordinate downstream systems should not be overlooked. I see an analogy to the session ID in RRDP and how sessions are resumable in RTR, similar to how TCP fast open cookies are handled. And I think mechanisms like this are useful and arguably help conserve resources. So I would encourage you to pursue this work.
Thank you very much.
I see a question on the chat. Lars Pren asks, how much downtime would currently deployed buffer sizes allow for if you are not currently in a burst?
We were thinking about that, and in the draft we were specifying a default value of 60 seconds. So the main goal is basically if you have a small interruption in connectivity between client and server, or you just want to restart the BMP server, that within that period of time, the router should be able to buffer the matrix. But of course, memory is limited on the BMP client, and therefore you cannot buffer for unlimited time. So if the time would be longer or the buffer would be filled, then you basically fall back to the previous principle that the BMP session is normally established again. Does that answer your question?
Lars types, thanks.
Cool, thanks.
Any other questions? I see that there are some implementers in the room, and I was wondering if maybe the Juniper people or Cisco people have previous experience with TCP fast open. Would this be an entirely new feature, or is it something that where existing frameworks can be leveraged in the operating system? Jeffrey?
So I don't know if we actually support TCP fast open in either of our two big stacks. I'm vaguely familiar with the feature. The thing I would, I guess, comment to Thomas is that the amount of state that needs to be sort of kept in flight is stuff that the kernel would have already owned anyway from the TCP portion of things, and
Exactly.
maybe some state that BMP had serialized at that point. But anything that's not in that category is basically unserialized state that's still in the state machine, and that shouldn't cost any additional memory. So the main considerations from my perspective, without having read the RFC in detail for some time, is that really as long as your kernel can hide the details about the session being lost from the application to some extent, I don't expect there to be much difficulty in implementing this. So I think that this would probably be a good mechanism, if the RFC covers the necessary things. If there's any chance for any lost state, the problem we have here is that there's really no way to easily recover this sort of thing because we don't have sequencing present in the BMP protocol. So those sorts of losses are problematic, but if that's not the case, this is not a bad thing. I think the major challenge for most vendors for real routers rather than easy host stacks is that nonstop routing TCP extensions are very messy and complicated as it already is. And to some extent, well, I think that the fast open stuff has some good balances with those features. The interactions are already very complicated.
I see. That's very useful. Thank you for your feedback.
Yeah. This working group should realize that the seamlessness can be solved at multiple layers of the stack. So the current proposal is to leverage existing work in, for instance, the Linux TCP kernel stack to allow to resume a session, but it's not the only path. We can also resume the session within the BMP protocol itself. And there's pros and cons to both approaches, but both approaches will give us the same result, namely avoiding duplicating, avoiding resending information that was sent previously and is still in the buffers of the client. But with this in mind, let's just explore one path, and if we somehow encounter an issue, or if there are negative interactions with graceful restart, or who knows what crazy things exist in the wild, then we can revisit it, and the resumption mechanism can be put at a different layer.
Exactly.
Jeffrey Haas comments, graceful restart should not be an issue. I hope so.
Good. Then thank you very much.
Thank you for your time, Thomas. And with that, I'm looking into the room to find Michael McBride to give us an update on ASPath prepending. The floor is yours. I can see you, but not hear you yet.
Can you hear me okay?
Yes, we have audio.
Okay,
Excellent.
I just took off Bluetooth. Yeah, okay, good.
Do you want to share your screen?
Yeah, let me do that. We good? See that?
Let's give it another second. On my screen, it says a screen share is being started. So I'm not seeing the slides yet. I'm seeing your desktop. If you go full screen, I think, yeah, perfect. All right, I'm going to mute myself. Take it away.
All right, very good. So I thought it'd be a good idea to give a brief update. We did present this draft last IETF. We've received many comments. Thank you so much. We've incorporated all of them. We just received one this morning from Thomas. Thank you very much. We'll incorporate that comment in the memory section of this draft. In the next rev. That comment was regarding BGP's impact on IPFix net flow. And so Jacob wrote that section, and we'll make sure we get that section updated. So thank you, Thomas. And we've had we've also had several people, several authors changing affiliations, so we updated that as well. So the background, just real briefly, is that Doug Midori, he did present ASPath prepending at a NANOG, and there was participants asked if there was any sort of a PCP coming out of IETF or any other SDO, and there was the answer was no. And so we thought it'd probably be a good idea in this working group to have an opinion on ASPath prepending. The problem is that excess of ASPath prepending has caused routing issues on the internet. And so we intend in this document to provide some guidance with how best to utilize ASPath prepending in order to avoid negatively affecting the internet, and to also offer some alternatives. We've also, per the working group's request, anonymized the real world examples, and we've used documentation prefixes and ASs. We've included a variety of use cases where it's ASPath prepending is in use today, including preferring one ISP over another ISP, preferring one ASBR over another ASBR, utilizing one path exclusively and another solely as backup, to signal to indicate one path may have a different amount of capacity than another. And an ISP doesn't accept traffic engineering using BGP communities, so pre-panning is the only option. So some of the examples of the problems, again, you can look at the draft, but you could have an attacker wanting to intercept or manipulate traffic to a prefix and then enlist the data center to allow announcements of that same prefix with a fabricated shorter AS path, and that malicious route would be preferred due to the shortened AS path, and that has happened. And then there's also been some routing leaks from one country that are being preferred over another country because of excessively prepended AS paths. And in that case, illegitimate routes are preferred, can be preferred over legitimate routes. And as was mentioned, and this is the comment that Thomas made, was long AS paths can cause an increase in memory usage among BGP speakers. There are alternatives to AS path prepend. You can use predefined communities that are mapped to a particular behavior. When propagated, you can announce more specific routes on the preferred path. Robert is a fan of using IGP or EGP origin, which takes precedence over an incomplete origin code and keeping the path lengths the same. And so we include that in the draft. There may be others, but I think probably that's all important, but I think probably the most important is the best practices. And in bold here is what we've added since the last Rev. Jeff Houston offered these suggestions, and so we included those. So let me just go over them real quickly. So network operators should ensure prepending is absolutely necessary, as many networks have excessive prepending, and it is best to enumerate when the routing policies are intended to achieve what the routing policies are intended to achieve before concluding that prepending is a solution. And he also pointed out that the neighbor you are prepending may have an unconditional preference for customer routes and prepending doesn't work. And so it's helpful to check with neighbors to see if they would honor the prepend. And so that was a good point that we included. We, based upon analysis that Doug had done, that he presented at NetHog, and we included in the draft that there's no need to prepend more than 5 ASs. And we include a diagram that shows that 90% of AS path lengths are 5 ASs or fewer in length. Don't prepend ASNs that you don't own, and prepending to all is needless. So we welcome more comments, including right now, if anybody has any.
In the chat, I see a comment from Jeffrey Haas. For AS path prepending, communities are effectively scoped one AS over, which doesn't help stop ASNs in many cases. Jeffrey, can you perhaps elaborate?
Sure. Presentations in this working group, as an example, people talk about their community policies. People are very strong about how they actually do their filtering on stuff. The chair, as an example, is part of an organization that is, very strictly scrubs the communities that pass through their system. So the problem with the with using communities to shape traffic is that if you can't get your behavior that you desire using some sort of community addressed to your adjacent ISP, there's probably not anything you can do about the next hop over. So for traffic control for AS single hop, communities can be very, very helpful, especially if you're doing things like selectively leaking more specifics. But once you get past that point, the practice that has held up over the years, for more than one hop, unfortunately, has been prepending. And while I generally agree that the number 5 is probably fairly reasonable, the sort of challenge that you end up running into, which Jeff Houston would recognize as a BGP wedgie, from the RFC that he put out on the topic, is that if you don't have something that is strongly prepended sometimes near the beginning, it's like maybe if you think you only need string maybe 2 ASs away, if you only add an additional 2 ASs into the path, there's a chance that route selection may cause something to wedge a little bit earlier, 1 or 2 ASs, closer to things. And unfortunately, a lot of these headaches just have to do with the topology of the internet. We've gone very much closer to hub and spoke. The core has continued to condense over the years, but if you happen to be a stub AS that is purchasing multiple streams of service from different providers, sometimes if you're not close enough to the core, your traffic forwarding is not as you expect, and especially as a smaller provider, your circuit costs can be wildly different in terms of how much you pay for such things.
Okay.
Next up in the queue, Ben Madison.
Can you hear me okay?
Perfect. Go ahead.
So I just want to make a point about what Jeff was talking about the scope of communities. I'm not sure that one hop radius is true in general. Certainly for us, we scrub anything that's in the well-known space or starts with a private AS, and we're very strict about what we accept in our namespace. But everything other than that, we leave untouched. So, for example, one of our customers can send a community in one of our transit's namespace and expect that to be honored at our transit's boundary. And I know of customers that do use that. I think the limitation is that if your transit happens to be a inverted commas tier 1 or a transit free network, the next hop over is going to be a peer or another customer, and then unlikely to honor traffic engineering communities of any sort. But I don't think that the scope is limited by virtue of any scrubbing that necessarily happens at your immediate upstream's edge. Whether or not that's worth including in the draft or not, I'm not sure, but it certainly does mean that whether you've got alternatives gets complicated. I think the additional text that you've added about the fact that people will typically use local CREF to prefer customer routes is important. And I think you can probably go a bit further than it sounds like you've gone and point out that, save resorting to very, very aggressive deaggregation, you may find that there are scenarios where you just can't make the traffic come in the direction you want it to, and you've got to make peace with that or change provider. There isn't always a way of making it come in the way that you want it to, because we're talking about destination forwarding oriented protocol.
Thank you. So those are more good comments. We have to just decide whether we want to include that in the draft.
Yeah, something along the lines of, you may be up against a brick wall, you should probably stop banging your head on it.
Sure. Okay.
A challenge with documents of this type is that there is a multitude of audiences that have to interpret this recommendation and apply it to their local situation. And on the one hand, there's the group of people who self-inflict harm by needlessly prepending themselves, which negates the efforts of, say, origin validation. But on the other hand, there is, of course, legitimate use cases of traffic engineering or traffic engineering use cases that applied in the past, but conflicts did not get updated. So it's a bit tricky how to navigate what it is we want to teach the reader. And I feel that the number 5 appears almost arbitrary, but on the other hand, some recommendation is perhaps better than fake hand waving, keep it as short as possible. But these are comments with just my working group participant hat on. I see that Rudiger Volk joined the queue. Rudiger, the floor is yours. Rudiger, I cannot hear you. There seems to be some kind of connection issue.
There's been some good comments on the chat as well that we'll
yeah, let's roll up to those.
Yeah, see if we can we should be able to add some of your comments, Jeffrey, and others into the draft as well. It's useful.
So Lars Prun says, can you explain why the average AS path length affects the number of used prepend sizes? If I want to differentiate between the preference of n peers, I need up to n-1 different prepending sizes. From my own experience, the average internet path length should just limit the maximum useful difference between any two of those n-1 sizes.
Yeah, so the thought there was that, if there's maximum, or if there's an average of 5 AS paths in the internet, then prepending 10 times doesn't do you any good. That's the general reasoning behind us putting in there. And to another comment on, if 5 is arbitrary, I'm not sure how arbitrary that is, and I think the draft is trying to show that it's not that arbitrary, because that's 90% of the AS path lengths in the internet are 5 AS paths or less. So that's why we put that number in there. If you think that's not a wise thing, then we can avoid doing so. But like you said, I think we should have some recommendation in there.
Yeah, I see friction here between having a recommendation that currently 2021 is sensible, but on the other hand, it is hard coding a constant, and this is always in internet drafts a balance must be struck. What is useful in this context? I think from Lars's comments, another approach might be to say that you should not prepend more times than you have eBGP neighbors. That might apply to some smaller ISPs as a useful rule of thumb, or perhaps there are other mechanisms to arrive at the number 5, but not prescribe it as 5 is the magic number. But I'm doing a lot of talking. Let's go back to the queue. I saw Alexander and then Randy Bush, so we'll go through it in that order. Alexander, it's your turn.
Do you?
I can hear you.
Great. Hope others can hear me too. So, speaking about this draft and not limiting to this draft, as far as I understand, the idea is to limit the propagation of the elect routes by making the length of ice path of the valid routes less, or just preventing it from being meaningless big. So it's easy. So the idea that you should not prepend more than 2 or 3 times or whatever, it's very clear. And there is another side of the medal, and maybe it's a good opportunity to cite it in one of the documents. That if you here you are speaking about from the perspective of the victim, of the source of the route, of the prefix of the address space, whose traffic is redirected by the route leg. This is another side, the sender. the receiver of the route link, who sends the traffic into a black hole or in the middle. It doesn't really matter. And there is another simple, stupid idea here, that if you have a flat policy, I mean that, for example, if you are a content provider, if you have just same local preference values for all your peers, you are getting really good protected against route leaks, because the route leak will have a bigger ice path, and it will be it will not become a best route for you. So maybe a suggestion that do not use multiple layers of local preference. For example, making one layer for access, another layer for the private peers. It's really not that useful and can become harmful. I'm not sure if it should be part of this document, but maybe it's a good idea to be cited.
Yeah, maybe so. Thanks. We'll think about that.
Comments, questions?
I took my hand down because my elbow got tired.
The floor is yours.
If we can't describe a clear and simple algorithm for the recommendation of how many to prepend to whom, then we shouldn't be talking about it at all. Right? Then we're blowing smoke. So I think we should be discussing a clear and simple algorithm for how many prepends.
Speaking as participant, I think I agree that a draft merely stipulating too much is harmful without us being able to quantify what too much means in a various number of scenarios is indeed not productive. But I hope this working group will be able to come up with a recommendation, because there are measurable effects to people prepending more than is good for their own environment. Ben Madison, the microphone is yours.
So I agree that in a perfect world we'd be able to set out exactly how the reader can arrive at the magic number. But I don't think that there is necessarily a one-size-fits-all way of determining that, because it's dependent partly on where in the internet you're performing the calculation. I don't think that there's anything wrong with saying in the draft that in 2021 that number appears to be approximately 5, but if you're reading this in 10 years' time, your mileage may vary. I think that's a reasonable compromise between additional complication and making it relatively useful. Just quickly, another point that I forgot to make when I was talking last, I think that the stuff around the origin code is a little silly, personally. I think mostly the reason that it's effective is because most receivers tend to just ignore it because it doesn't actually change their path selection process meaningfully. And I think that if people started actively using it at scale to do traffic engineering, you'd find that people just reset it on their borders and the effect goes away. I don't think that's a recommendation that we should be making to people.
Okay.
Next up, Jared March.
Yeah, I find myself agreeing with Randy and Ben to some extent. Of the shape of the internet has changed significantly over the past, 25 years or so that I've been meddling with it, and the question of what the diameter is and what service providers support what and have what capability, I think is something that lends itself to how do we measure this? How can we describe what is harmful? And then how can, we've been damaged in the past with prior implementations. And so we have ASPath limitations implemented in the 20940 network that limit ASPaths to 128, which is probably a safe protectionist number, but is also driven by prior software defects. And so identifying a number that is appropriate and based upon what service providers have what capabilities, I think is, and coming back to that with a way to describe that to protocol implementers to say this number is okay and this number is not, I think is going to be really difficult for this group to undertake, just based on the role and position and the topology of the internet. That's it.
Thanks.
Two people are in the queue, Randy and Jeffrey. We'll start with Randy, and then there's an opportunity for Mike to answer if there is an answer, and then it's up to Jeffrey. Randy, go ahead.
Ben, if where I am in the topology is part of the consideration for how I prepend, then that's fine. I didn't say the algorithm is based strictly on how many peers I have or what color Wednesday is. But if we can't give solid guidance, then this isn't going to last. And saying this worked well in 2021, but take a flyer in 2023, that's not really reasonable. I think if we can't give guidance here, then we really don't know what we're talking about.
Jeffrey?
So the one thing I will follow up on from what Jared had mentioned that might be worth discussing in the document is the bugs that have happened from prepending. And the single biggest one is just simply segment overflow in the ASPath. ASPath basically says, here's the number of ASs for this segment type. There could be at most 255 in a given segment. If you want to go to two segments in a row that are the same type, you have to add a new segment. And an awful lot of people had bugs, for a number of years that didn't get exercised until people like Ripe started playing around with these things experimentally, which people found to their horror when the internet started crashing. So it might be worthwhile mentioning that this is one of the possible contributors towards long paths being bad. Not necessarily that it's broken in BGP, but implementations often are broken in this respect, and something to watch out for.
I agree. We'll add that. And it looks like there's different opinions on using origin code, so we'll have to work that out as a working group.
The difference in opinion on origin code, what I understood from Razuk's contribution is that he merely posited that it may be possible to use the origin code as an alternative mechanism to accomplish the same as what was set out to accomplish with the prepending. Not that origin code is a better practice than prepending, just that he was enumerating was my understanding of it. But yes, origin code is not a reliable mechanism, just as AS path length also is not a reliable mechanism for traffic engineering in the wild internet. So since we're deprecating AS sets from the AS path attribute, does the group feel that that frees up for longer AS paths? No, I'm joking. Mike, my summary of the feedback on this presentation appears to be that the effort should be focused on seeing if nobody's questioning whether 5 is an appropriate number today based on the data it was derived from. But to make the document more future-proof, it would be good to set out to see if the number 5 can be constructed from different data sources that perhaps are more applicable to the local environment in which the operator resides reading the future BCP. The chairs are available if you want additional help in this regard, or maybe you have goals and plans, but I look forward to continued updates on this draft.
Great, thanks. Yeah, this has been very helpful.
Thank you for your time, Mike. With that, we have arrived at the top of the hour, and I would like to conclude this GROW session. The next IETF session will be, or will not be, in San Francisco, but it will be numbered IETF 101. And we hope to see everybody there again. Thank you for your time today. Thank you for your contributions in chat and at the microphone. And I wish you a pleasant day. The chats are saved, yes. So how do we end a meeting?
It's going to be a long while because we need wraparound to get to 101 in San Francisco.
Sorry, can you repeat that?
San Francisco will be 111, not 101.
Oh, did I mispronounce? Rüdiger, I could hear you for a brief second.
Leaving the meeting, I guess the chair just leaves the room.
I will try that.
We can hang out here. Close your browser.
Yes, we watch it. Okay, no, it did not work. But, well, okay. That's not really a hard problem.
By the way,
you
said 5 was the right number right now. Please write down the justification for that algorithmically. And I am closing my browser. Ciao.